We're going to start lesson 2.2 with some vocabulary. So the graphs that we're making for sine and cosine are called sinusoids because they look like the sine function. So sinusoid is just a curve similar to the sine function. These curves have a similar looking equation. So you're going to have y equals, or f of x equals, a number here, c, plus a number a, times either sine or cosine, and then later on we'll do tangent, cosecant, secant, cotangent. Then you'll have a number here, b, and then times quantity theta minus a number d. So, and anytime you want, just pause this video and go ahead and write down these definitions. But I'm going to keep going ahead. So the cycle of one of these functions is a full rotation of the curve before it starts to repeat itself. So when I look here, one cycle would be up, down, and right before I start to go back up. So that's one full cycle right there. Just up, down, starting to go back up. Degrees, once you know what your cycle is, degrees is or period is the number of degrees it takes to make one cycle. So it usually takes 360 degrees in order to make one full cycle. The amplitude is the distance from the axis to the high or low point. We'll talk about what the sinusoidal axis is later, but right now you can just use the x-axis. So from the x-axis to the high point or the low point. Then critical points in the graph are where something important is happening. So in the graphs, that's anytime it hits the x-axis, so a 0, or anytime it's hitting its maximum or minimum point. And those, to start off with, are always going to be your at 0, 90, 180, 270, and 360. So we're going to look at this picture here, and we're going to label the vocab looking at this curve. Let's start with a cycle. So pick anywhere on the curve you want to start. Let's say I want to start right here. If that's where my cycle starts, then I can trace my curve. It goes down, it goes up. It's never hit a high point yet, so even though I'm level, I need to keep going past the high point, and then here I notice it starts to go back down the exact same way it started. So from here to here is one full cycle. Here to here is one full cycle of a graph. One cycle. So once we know our starting and ending point, and again, you choose your starting point and then trace the curve to find your ending point, then you can figure out what the period of the cycle is. So the period is the number of degrees it takes to get from your starting point to your ending point. So you look down at your x-axis, and the amount of degrees it takes to get from start to end, that is your period. Now in this case, we're starting somewhere between negative 180 and negative 270 and ending between 90 and 180. So this is going to have a period of 360. Then let's look at amplitude. Amplitude is the distance from your axis to your high point. So from the axis to the high point, right there, that space is your amplitude. Or you could go from your axis to your low point. It's one or the other. Don't go from low point to high point, but from the middle to the top. It's your amplitude. Here it's 1. So here this has an amplitude of 1. Here it also has an amplitude of 1 because it's going down 1. But it's the distance, so we keep that positive. Last thing, vocab-wise, is your critical numbers. So we see anytime where it hits 0, which would be 360, is a critical number. 180, 0, 180, 360. These are all critical numbers because they are the zeros of the function. And then we also have 270 because it's a max. Negative 90 is a min. 90 is a max. 270 is a min. So all those orange points are your critical points, and all we really need to graph are these orange points, and then we should be able to make the sinusoid just using those, and we don't need all these little points in between. In example 1, we're changing the amplitude of the function. So that means there's going to be a number being multiplied in front of your sinusoid. When it's a whole number like this, you're going to be stretching your sinusoid. It's going to be taller than normal. Usually it's up 1, down 1. In this case, it's going to be up 2, down 2. When it's a fraction, then you are compressing or dilating your amplitude, so that means it's going to be shorter. So it's going to only go up a half and down a half instead of up 1 and down 1. You can either go right into making this graph, or you can make a table for it. Let's go ahead and make a table. So we notice that theta is not changing. There's no number on our theta. So we're going to go ahead and put in our normal critical values from our unit circle. So 0 to 360. Then let's go ahead and put our normal sine values. You can get these from your unit circle, or you can go back to lesson 2.1 and look at your y values on the table there. So sine starts at 0, up 1, 0, down 1, 0. Now there's a 2 on these sine values, so that means we're going to take those sine values times 2. So 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is 0, negative 2, 0. So when we plot our points, theta did not change. We keep those theta values. Our y values did change. Now they're going up 2 and down 2 instead of the 1s. And let's plot those points. So starting on my x-axis, I have 0, 90, 180, 270, 360. And then on the y axis, we go up 2 and down 2. 0 is at 0, 90 is at 2, 180 is at 0, 270 is negative 2, 360 is 0. Make that not ugly. Put arrows on the end, and let's quickly just go ahead and state our domain and range. Domain is negative infinity to infinity because there are arrows on the end. And remember, domain is left and right. Range is up and down. The lowest point it goes is negative 2. There's a bracket because it actually has a filled in point. It touches negative 2. And then the highest point it goes to is positive 2 on the y. And bracket on that because it actually touches positive 2. So go ahead, pause the video, see if you can make a table for the next one and graph it. I'm going to do the same, and then we'll check our answers. Okay, let's check your table with mine. So theta did not change because there's no number on the theta affecting it. So that means your theta value should be 0 to 360. So your theta values should be the same as they always are. Then you should have done your cosine values, which are 1, 0, negative 1, 0, 1. You can look at your unit circle for that, or you can look at your lesson 2.1. Now, in front of cosine, there was a 1/2. So that means we need to take all the cosine numbers and multiply them by a half. And you should have gotten 1/2, 0, negative 1/2, positive 1/2. So those are the new y values that you plot, because they have changed the amplitude. So on my graph, I'm going to put a point at 0, 1/2. 90 is at 0. 180 is at negative 1/2. 270 is at 0. 360 is at positive 1/2 again. And then connect these with a smooth curve. And that should be your graph. So it should look shorter. Your domain is the same because the x's did not change. There's still arrows left and right. Range, it goes down to negative 1/2 this time and up to positive 1/2 this time. In example 2, we're changing the cycle or the period. So you're going to see numbers now being multiplied to your theta. So here we're multiplying by 2, here we're multiplying by 1/2. So the theta values are different. But the y values will not be different because we're not multiplying anything in front of the sine or cosine like we did in example 1. So this is going to change your theta column. Let's go ahead and start with our original theta column. 0, 90, 180, 270, 360. And then anytime you do something to theta, you want to actually do the opposite in your table. So if it says 2 times theta, we're going to divide these by 2. So always do the opposite. So it says multiply by 2, so in the table you divide by 2. So 0 divided by 2 will still be 0. 90 will become 45. 180 will be 90. 270 will be 135. 360 will be 180. So the 2 actually means that this graph will complete 2 full cycles before it ever hits 360. So this is showing 1 full cycle only takes 180 degrees for 1 full cycle, when normally it takes 360. So this rotates or oscillates a lot faster. Then we go ahead and put our sine values, just our normal sine values. We've already changed theta, so we don't need to put the 2 there. And you're going to get 0, 1, 0, negative 1, 0. So when we plot our ordered pairs, we're looking at these theta values where we divided by 2 and these sine values where we didn't change them. So let's put that in the graph. We're going up 1 on the y, down 1 on the y. We've got x values, or theta values of 0, 45, 90, 135, and 180. And then you plot your points, 0, 0, 45, 1, 90, 0, 135, negative 1, 180, 0. Connect these with a smooth curve. And there's your graph. Domain, negative infinity to infinity. Range is negative 1 to 1. Go ahead and pause the video and try the next example. This is what your table should look like. The 1/2 means we want, instead of multiplying by 1/2, we want to divide by 1/2. But you know, with fractions that you can't divide by a fraction, you actually need to multiply by the reciprocal. So actually we're multiplying by 2. So I took all of my theta values and multiplied them by 2. That's where I got 0 through 720. These are the new theta values that we're going to graph. And I went ahead and put them on my x-axis, which is my theta axis. And then cosine had no numbers in front, so that means we are not messing with the y values. We're still going to use 1, 0, negative 1, 0, 1. So on my graph, 0 is at 1, 180 is at 0, 360 is at negative 1, 540 is at 0, 720 is at 1. So we saw the 1/2 changed our cycle, and what that really tells me is that you're only going to complete half of a cycle within 360 degrees. And we see from 0 to 360, it's only half of a cycle. It was only up to down. You didn't go back up. So that's what the 1/2 tells you.